Hello friends, Joe here from HackerBoxes. Today we're going to learn how to solder. And we're going to learn to solder using this cool little kit, which we call a BadgeBuddy. It has some blinking LEDs and a battery and a switch. So not many components. It's pretty easy to make. It's a nice first start if you haven't soldered before. So first let's talk about what is soldering. So soldering is just melting solder, which is a metal alloy that has a very low melting point. So we melt the solder using a soldering iron, a tool like this, and we melt it between things that we want to connect together, usually connecting them electrically, although we will discuss that there's more to it than that. We see things that are soldered all the time, and we have the entire world around us is full of electronic gizmos that have components soldered onto circuit boards. So it's a big part of our lives, whether we stop and think about it or not. Being able to solder is a really nice skill to have because you can repair things, modify things, connect wires to things to read data in and out of them. It's a really excellent hacker skill, a nice DIY skill. Once you get into it, you'll find that it comes in handy a lot, and it's one of these skills that you can kind of apply to a lot of different things. So, all right. I thought I would start by just saying, kind of big picture, there's kind of two things that we want to kind of keep in mind that are really important. The first one is pretty obvious, and it's almost sort of a joke. Probably seen these pictures online. This is a soldering iron. It's off, obviously. If it smells like chicken, you're holding it wrong, okay? Always hold the rubber handle. So that's the first big picture item. The next big picture item is to realize that you always need more solder. And I don't mean by that you need to go out and always buy some more solder because you need to have lots of solder. But when you're working on some work that needs to be soldered, you'll find initially that generally you need more solder than you think you need. And when something isn't working right, you need to add more solder to it. And sometimes that's counterintuitive, especially when we're trying to unsolder something. Adding more solder is a vital part of unsoldering. So just keep those two things in mind. The first one's obvious. The second one can be a little counterintuitive. Smells like chicken, you're doing it wrong. Number two, you probably always need more solder. Just don't be afraid to add more solder. Okay, so solder serves three purposes, and I think this is one of these important things because there's some subtle importance to these three different things, and they're different, and in contained in the fact that these three things that solder does are separate jobs of the solder. Contained in that are some of the common problems that people have as they're getting into soldering. So the first one is almost obvious. It's that soldering mechanically connects two things. So it's almost like glue. You're almost using it like a hot glue. You melt it between two things and it connects them. But is that enough? Certainly not, because really often the main point of the solder, aside just holding two things together, is you have to have a good electrical connection, something that current will flow through, not something that will easily break apart, and not something that actually has small gaps in it. So if you go at it thinking, I just need to get these two things stuck together like glue, and you don't think about needing to have that really nice electrical bond, you might be missing something. And the third thing, this is the part that's a little subtle that often people miss in the very beginning, and usually this is one of these things where when you get this, usually your soldering game goes up to the next level. And that's that one of the jobs of the solder is actually a thermal conductor. And what I mean by that is, because there's two different ways that that's true, but the one that's really important is that it is the solder that allows heat to flow from the soldering iron onto the work. Okay, so if you don't have solder in the play before you even start soldering, in other words, if your tip isn't tinned, if you don't have the pieces of work, meaning the wire and the pad or whatever it is you're trying to solder together, you don't have solder in play, there won't be a thermal conduit for heat to go from the tip of the soldering iron into the work, which is really what you want to do, as we'll discuss. So just remember that part of the job of the solder is to actually be a thermal conductor. Okay, so it's a mechanical bond, it's an electrical conductor, but it's also a thermal conductor. And the second way in which it's a thermal conductor is in some instances where you have components that get warm while they're operating. So maybe let's say a linear regulator or something. It being bonded with solder onto a PCB or some other substrate can allow the thermal energy to flow out of it to keep it cool so it doesn't overheat. So that's kind of a secondary way. But what I'm really talking about when I say this subtle thing about thermal conduction is while you're soldering, you need the solder to help do the soldering, okay? It isn't just a glue. It's actually a conduit of the making of the connection. All right, so try to keep that in mind. So let's talk about some of the tools and supplies that we use when we're soldering. The first obvious one is a soldering iron. So the really cool thing about soldering irons is in the last 15 years or so, the price profile of soldering irons has changed quite a lot. Now for what would have been unheard of 20, 30 years ago, you can get for a price that would have been unheard of, meaning even as little as like $20, $30, $40, you can get a very nice soldering iron. I know the soldering irons, that I came up wishing that I could have had, but I only had access to in a lab because they were $250. Now, we get soldering irons all the time that are in the $20 range that are of similar quality, controllable temperature and very nice, tips that stay very clean for a very long time. So that's a nice thing is soldering irons are readily available now, and they're not super expensive. I mean, you can still spend a lot of money on a really nice soldering iron, but generally what you really want is just one that has a nice quality tip that's replaceable. Although you'll find you might not actually need to replace it very much if it's a nice tip, and you need to be able to adjust the temperature because there are times when you want a little more heat on the tip or a little less heat. You also just don't want it to just always be some preset random amount. So, really inexpensive soldering irons don't have a temperature adjustment. All right, and another tool or part of a tool you'll need is you'll need to always be able to clean the tip of your soldering iron. You basically have to keep it clean all the time. If you're thinking always clean the tip or constantly clean the tip, you'll end up cleaning it a lot, which is what you really need. You need to clean that tip very, very frequently while you're using it. It's not just something you do at the very end while you're putting it away. So most soldering iron stands come with a little SpongeBob square sponge like this that's just at the bottom of the stand. Just get that wet. Some people keep a little bottle, like a little drinking water bottle next to their soldering station, so they can always just keep that thing wet without having to run off to get it into the sink. That's fine for when you're starting out. Just rub it on that sponge. Rub the tip of your iron on that sponge frequently, like almost every time you put the soldering iron down or pick it up. Just constantly be cleaning it. And then as you get a little more into soldering, kind of like a style point tool is you might get one of these little kind of shaved metal tip cleaners. And these are pretty nice. You make sure to get this in the camera right here. You just kind of stab the soldering iron into it, scrape, and it scrapes the tip of the soldering iron. You can just do that frequently while you're using it. Every time you go to set the soldering iron down or pick it up, just kind of stab it in there a couple times. So the nice thing about the metal, the kind of it's almost like a little Brillo pad. It's like I think they're usually made of brass, and it's like metal wool. I think people call it metal wool or steel wool. It's not technically steel wool, but these type of cleaners, the really nice thing about them is because they're not wet, they don't conduct as much heat away. So that's really good. Yeah, so those are probably the main tools you need. It's also nice to have some flush cutters, like these little guys, which are really very tiny, and one side of them is flat, so you can cut wires off flush to a circuit board. At some point, you will want to be able to remove the residue that's left on a circuit board after you solder it. This is called cleaning the flux. So you'll want a flux cleaner, or a lot of people just use rubbing alcohol isopropanol and a little very stiff brush, an acid brush, to just clean the back of the board. In the beginning, you didn't really need to worry about that too much. You can, just clean it with a tissue, or just, don't worry about it too much for a board like the one we're going to do today. But when you start making circuit boards you want to be able to keep for a while, you want to be able to take that residue off. And we'll discuss why you want to do that. So you'll want the whatever solvent you're going to use for that. Like I said, isopropanol is usually fine, and maybe a little brush or something. And at some point you're going to want to have flux that you can deliver to the board. Flux is the thing that cleans the work. It cleans the surface that you're going to be soldering on. It also breaks the surface tension of the solder when it's liquid so that it can flow a little easier. So it's a cleaner and a flowing agent, and flux is just kind of important. I have heard some people refer to flux as grease. So if you heard people say that, that's what they mean, but it's not grease. It comes in a liquid or a gel, or it comes in little pen dispensers that look like a fat magic marker. A lot of people these days really like the gel. That's become readily available. I usually use the liquid just because that's what I've always used, and I get a little dispenser bottle. Let me see if I have one of these, a little dispenser bottle. These are extremely inexpensive, so you can have a few of them loaded up, and you can see the flux that I have in there is a liquid. So you're going to want some flux. So the like I said, there's a bunch of different kinds of flux. The most basic kind of flux is rosin. I don't know if it says it on here. It says flux on there. I don't know if you can see it. It's very tiny, but for the most part, all the solders you're going to use, we'll discuss solder again in a second. They're rosin core, meaning they have rosin flux inside the solder. So when you're using the solder, it's kind of auto fluxing. It's self fluxing. So you don't need to apply flux from a pen or a bottle. But as you get a little more advanced in soldering, you're going to want to have flux. But for the very beginning, using the flux that's inside the solder is totally acceptable. You'll be able to get away with doing a lot of work just using the flux that's inside the solder. But I'll speak more to that in a minute. There are some things you have to keep in mind when you're using the flux in the solder. So that flux is what leaves a residue on the board sometimes when it's when you're done soldering, and you might want to clean that off, because the way the flux cleans the surfaces, it's usually an acid. It's not a super strong acid, but it's acidic, and if you leave it on there, it's great when you're trying to solder, because it'll clean the oxidation and dirt and oils off of the work, so that your solder will flow. But if you leave it sitting on there for a long time, it might eat into the board a little bit or pit the surface, and plus it just usually looks a little yucky. So it's kind of nice to clean it off. But for your first few projects, and certainly for this soldering this first BadgeBuddy, don't worry about that. So but just know what flux is. At the point where you want to start cleaning flux or using a separately applied flux other than just the flux core and the solder, it'll come to your mind that, oh, I want this other thing, and just, worry about it then. Okay. You don't need to worry about that for right now. So, but yeah, so as far as the solder goes, there's a lot of different options when it comes to solder. The basic options are, tin lead alloy, just basic, a lot of people call it 60-40, although there's slight variations. They're not always exactly 60-40, 60%. I think it's 60% lead, 40% tin, or it might be the other way around. I'm not sure, but let's see, it might tell us on here. 60% tin, 40% lead. That's kind of the basic solder. It has like I said, it has a flux core in it, and this one right here, you can see it's fairly thin. This is a 0.6 millimeter solder. I usually get 0.6 or 0.8 millimeter. I've used 1 millimeter before too. That's fine as well. But you generally want something that's fairly thin. If it's too thin, when you're soldering something larger, like a connector or something that has like a big heat pad or something, you'll find that you need to use a long length of it. That's not a big deal. Just use a little more. Some people like to have a thicker one for doing stuff like that, and then the thinner one for doing smaller work. That's nothing you really need to worry about right now. One thing I do want to comment on is a lot of people get caught up in the lead-free solder, and of course, we'll talk about safety in a little bit. Lead is a potentially toxic substance, so if you're concerned about it, you can use lead-free solder. I don't. Most people that are really into soldering really hate lead-free solder. It has a much higher melting point. It's very annoying to work with. It's really hard to rework. It's just not the best thing in the world. And if you're pretty careful, you shouldn't be sticking soldered wires or circuit boards in your mouth anyway, or letting children play with them. So you don't get lead inside of you simply by touching it. You have to touch it and then lick your hands, or you have to chew on the thing that has the lead on it. Lead doesn't just float up in the air. So, of course, if you're working somewhere and they have a safety policies on this, read your safety data sheets and all that. That's not my expertise, but, I can just tell you that most people that are soldering experts, they prefer to use the standard 60-40 leaded solder. It's just much easier to work with. And lead has a very low melting point. So anyway, those are the kind of solder things you need. Speaking of melting point, if your soldering iron has an adjustable temperature on it, a common question is, well, what do I set that at? So I usually set mine right at about 350 degrees. That's Celsius. Maybe a little higher than that sometimes, and that works out to about 660 Fahrenheit if you have an older rig that has a Fahrenheit rating on it. But so yeah, just kind of keep in mind like 350, 360, something like that. And you can go a little lower if you're working on something really fine and you're worried about heating it up too much, or a little higher if you're soldering like some big screw lugs or something that needs a lot more heat delivered. And if you kind of sense that your tip is getting cool too quickly, you might want to just turn the temperature up a few degrees. So remember that 350C or 660F will kind of keep you in the right range for melting the lead tin alloy solder. If you decide to use lead-free solder, you're going to need to go up a little bit, and you can find the specifications for whatever solder you're using. It'll have a melting point, but the tip temperature needs to be much higher than that melting point. So it'll usually have a melting point and then a specified tip temperature. All right, so so temperature, soldering irons are really hot. So we joked before about the chicken thing. I'm going to mention it a few times because you just want to be careful not to burn yourself. Like there's a few safety points to keep in mind here. That's probably the one that we almost don't need to mention. I mean, we're melting metal. Of course, it's hot. Don't stick your fingers in it. Don't clean it on your tongue. Don't all of those things, right? So just remember it's hot, okay? The next safety point, we're going to have 4 safety points. The first one is heat. Don't burn yourself, all right? Don't burn yourself. Don't burn your desk. Don't start a fire. Just remember it's hot, heat. The first one is heat, okay? Number 1, heat. Number 2 are fumes, okay? And a lot of people think this has something to do with the lead. It doesn't. It's when you're soldering, there's that rosin core in there, and the flux, that rosin core, it will gas off. It'll make kind of a smoky smoke, and you don't want to breathe that, all right? So you want to have a little, what I have on my workstation is I actually just have a small fan, and it just kind of blows into the corner, because that smoke, that residue, it'll settle very quickly. So if you just blow it away from your work, that's probably fine. I don't recommend this, but I've actually noticed even with my fan on, just because I've been soldering for so long, when I solder, every once in a while I'll just go and I'll just blow the smoke away. If the smoke is rising up into my face, I don't want to inhale it. So I just, and then I inhale. Probably not smart, probably not safe. Just keep the fan on. You can buy a really nice little fume extractor hood that has a little, like a filter. I think it's a charcoal filter in it that gets the soot trapped, and it's very nice. So if you're going to solder a lot, you might want to get one of those. You don't want to be breathing those fumes, okay? So number 1 was heat. Number 2 was fumes. Number 3 is lead. We already talked about the lead. When you're soldering with lead solder, lead can get on your hands, just like, if you were touching a lead pipe or something like that. Also, little bits of lead break off. I think it's called dross, and maybe even they're almost microscopic. Sometimes they are macroscopic, and you'll even notice little bits of little tiny balls of solder around your work area after you've soldered a lot. That stuff is called dross, and if that's sticking on your hands and then you lick your finger or you eat your lunch and haven't washed your hands, that lead can get in you. That is particularly a problem for children. So if you're soldering in an area where there's children, you want to clean that lead up. All right, after you work with leaded solder, you need to wash your hands, okay? And this isn't a hand sanitizer situation, because you're not trying to kill bacteria or something. You're literally trying to wash a metal away and get it off of your hands so that it doesn't get inside your stomach, in your mouth, okay? And also, if you have these little dross bits and there's a child that comes through your work area, and they're very little, and they might, drop a toy somewhere where you have these little dross droppings or whatever and put it in their mouth. Or if you've recently soldered something and they might say, oh, look, that's a cool BadgeBuddy, and stick it in their mouth. That's not cool. You don't want to get lead inside you. You do not want a child getting lead inside them, okay? It's not that big of a deal. There's other things in your house that's lead, but you do not want little chunks of lead, that break off of things sitting around. Just wipe it up with a wet wipe, wash your hands, clean it up. Just keep it clean. Don't get this lead around the place. Wash your hands after you work with leaded solder. All right, so heat, fumes, lead, right? Those are 3 things. And then this last one is huge because people just don't think about it that much. But please wear safety goggles. You don't want to fling a little drop of hot solder in your eye. A really big thing is you're cutting your leads off, especially ones that might be a little thick, and they go poof, and the lead flies off and it hits the wall. And you're always like, oh, that sounded nice. Well, that doesn't sound nice if it hits you in the eye, all right? You only get, you actually get 2 eyes. Anyway, you probably want to keep both of them. So protect them, wear some eye protection, all right? You only get those 2 eyes. All right, so great. So let's actually get to soldering now that we've covered sort of the theoretical background stuff. And I guess this might be a good time for me to say, there's a lot of great soldering videos out there. If you just get on YouTube and look for things about soldering, you'll hear mostly all these things I already said, but maybe you'll pick up some other pointers, and sometimes it's good to hear things explained from different people. So, if you like soldering and want to get better at it, definitely watch some other videos. We're only going to barely touch on, for example, surface mount soldering. So there's some great surface mount soldering videos out there you can find. So that nice segue to our next thing. I like to think of there being 3 structures for soldering. two of them we're going to do here today, and that's through-hole soldering. When you have a hole in a circuit board, like, it's called a through-hole, a plated through-hole, and you put a wire or a post through it, and then you solder it into that hole, right? There's through-hole soldering, and then there's surface mount soldering, where you have a pad on a circuit board and you solder something onto that pad, so it doesn't go through the board, it just solders onto the surface. And when you see these like really large chips that have many tens or even hundreds of little leads sticking out of the sides, those are all surface mounted, or these little tiny resistors that look like little rectangles that don't have any wires, like those are surface mounted. Today we're going to do one really big surface mount thing, and that's our battery clip, but it gives you the idea what surface mounting is, so it's a nice exposure for that. So we have through hole, surface mount. Through hole is sometimes called TH. Surface mount is often called SMT, surface mount technology. And then the third thing is just I guess I might call it point-to-point soldering, and it's when you just solder two wires together. You usually strip the two wires, twist them together, and then solder them, and making sure you get solder flowed completely into the joint. Another example of that kind of point-to-point soldering is when you're soldering a wire into a connector or something like that. So that isn't exactly through-hole, and it's not exactly surface mount. It's just a different kind of soldering. But if you always think of those three things, they all kind of work the same, but they all have little differences that it's nice to make sure you get some practice in doing all three of those. All right, so let's get right into this example. Actually, first let me just say, the basics of soldering are, we've already touched on this a little bit, so I'm going to say these things a few times just to make sure they really sink in. So you have let's say you just have two surfaces. You either have the hole with the wire in it, which is, the hole is a surface and the wire is a surface for through hole, or you have a pad with a terminal of a component sitting on the pad if it's surface mount. So, but there's usually two things, right? The pad and the lead, or the hole, the through hole and the lead, the plated through hole and the lead. And what you want to do is heat up the junction. So both of those things. You want to heat both of the things you're trying to connect hot enough so that solder will flow onto them. All right. So there's a few things that you're trying to do all at once here. So when you go to heat them, you need to have some solder between the soldering iron and the connection. And this is not the solder that you need to flow into the connection later. This is just the thermal connecting solder. So you have the two components sitting together. So often what you'll do is you'll have the two components, near each other in some way. They're next to each other, either inside of each other or sitting on top of each other. So you put the iron near them, get a little solder on it, on the iron, just so that solder can touch to the work and conduct heat into the work, right? So that's not the solder that makes the connection. It's the solder that is used. It's the solder that's used to enable the connection to be made by allowing the soldering iron to then heat the items up, right? So that first little bit of solder you put on there, you're really putting it on the iron, and it heats up the two items, right? That heats up the work, let's call it the work. And then once the work is hot enough, it's up to that melting point of solder, then you touch the solder to the work, not to the iron, and the work will melt the solder onto itself. And that's how you get a beautiful, nicely flowed solder connection, where the solder flows onto the work and is not just kind of being brushed on there by a soldering iron. All right. So again, you do not use the soldering iron to apply the solder. You use the soldering iron with a little preliminary bit of solder on it to heat up the work enough so then the solder melts onto the work. Right. So anyway, that's a thing that, when you get that really nice flow of solder on something, when you have the metal really hot, and then the metal melts the solder, not the soldering iron. The soldering iron merely heats the metal up. The trick is you need a little solder initially to be able to get the heat from the soldering iron into the metal or the work. So that's one of the main things you're doing there. The other thing is, remember, your solder has especially, if you don't have a bottle of flux, you're just using rosin core solder. Your solder has your flux in it. So you need to be adding solder. I don't want to say constantly, but the process of making the solder connection, you need to be adding solder, because the flux comes out when you melt the solder. All right. So before you make the connection between the two pieces of metal, those surfaces need to be they need to have flux on them. So you have to melt the solder in their vicinity so that the flux gets on them, and then that allows the solder to flow onto them. So the two things kind of happen at once: the heating and flowing of solder and the application of flux, because they're coming in the same delivery package, right? The strand of flux you're using has the rosin the strand of solder you're using has the rosin flux inside of it. Okay. And another important thing about that is, sometimes when you get solder on a connection and you're moving it around or you're still working the connection in some way, the smoke that came up, that's your flux burning. It's your flux boiling off. That smoke that came up that got sucked away, or that, if you followed my incorrect instructions, you blew away. So now that flux is gone. Okay, so that's one of these things where you need to add more solder, because the solder has the more flux in it, right? So if you're continuing to work the item, you only have so long before your flux is gone. Okay, and then if you get to the point where you've melted a bunch of solder on it and there's this big mess, you need to take the solder away, which sometimes you can just lift it off with the iron. It'll stick on the iron and you can clean it on your sponge or your metal tip cleaner, and then you can apply some more fresh solder, which will have new flux in it, and releasing a little more smoke. So this is part of that thing I said where you need to be always ready to put a little more solder on, because you need the solder because it conducts the heat. You also need the solder because it has the flux inside of it, and the flux doesn't stick around. You only get a few seconds to use to flux the surface with the solder. That's why you need to keep adding more solder. Even if then you get to the point where there's too much metal on there, too much solder, you just pull it off, just clean it off. You're gonna need the flux. And when you get a little more advanced with this stuff and you're doing a lot of connections, really small packages that have a lot of pins, that's where you just want to get a bottle of flux and just drench the thing with flux, or put gel flux on it so it's all soaked with flux, because then you can work it, you can move the solder around, you can add and remove solder, and the flux is still there doing its job of cleaning and breaking the surface tension of the molten solder. Let's get on with this little kit here. So this is the BadgeBuddy. Comes in a Ziploc bag like this, and there's some stickers in there. If you got this during DEF CON 28, we did some sticker swapping. So there's a bunch of different stickers in here from lots of our friends and members in the community and other vendors, and you see such as Hack5 and Hacker Warehouse, and just random stickers. So that's lots of fun. And let's see. Yeah, there's some good ones in here. Yeah, there's the Hack5 sticker. A couple Hacker Boxes stickers. Hologram sticker. Hacker Warehouse gave us these. They have some little camera covers on them to keep your camera safe. So, all right, the parts that are in here are fairly basic and represent opportunity to do a little bit of surface mount and also some through-hole soldering. There's a bead chain that you can use to connect the BadgeBuddy to your lanyard or your backpack or whatever when you're done. Use a coin cell battery. It's a lithium battery, a CR2032. It's a pretty common lithium battery, coin cell. And that's the clip that holds the coin cell onto the back of the PCB. Alrighty, so let's get these things out of our way here. Solder these 4 items to the PCB, to the circuit board with logo on there. There's the Hacker Box's logo. His name's Bithead or Circuit Head, depending on which version he is. So we're going to get some solder out. We're going to start by tinning the tip of the soldering iron. This one's already tinned because we use it a lot. And then we're going to tin these 3 pads, these surface mount pads on the board. But you want to always keep the tip of your soldering iron tinned. Keep some solder on it. It'll get, the flux will help clean it. And every time you see the soldering iron going off the screen here, that's just me cleaning the tip in a tip cleaner. So we're going to tin these 3 pads by just getting some solder flowed onto them. And again, we're not just melting it on there. It's actually bonding into the pad, the solder that's already on the pad from the manufacturing process. So. And when you're surface mount soldering, with any soldering, you really want to pay attention to the orientation. So this little clip is oriented according to the white paint on the board that's called the silk screen. So the board has been silk screened with these positioning indicators, and most boards have this. when you lay out a circuit board, you can design the silkscreen. So the silkscreen shows you which direction that the battery holder goes in. And in this case, you could put it the other way. It's just a little harder to put it in. So we intentionally oriented it so the clip opens downward. So now what we're doing is we're getting solder to flow onto the little wings on the side of this battery clip, battery holder, and we're actually heating the clip up enough so that solder flows onto it. So remember, we need a little solder on there just to conduct into the metal of the clip, and then you can see the solder flows really nicely and makes a nice shiny surface. So you want to make sure when you're soldering, you always end up with a shiny surface that flows neatly onto all of the metal around it. And that lets you know you do not have what's called a cold solder joint. If you just dump hot solder on a cold metal, it won't flow onto the metal and it won't bond. And that will be a cold joint, which is mechanically unstable and can be broken off pretty easily. And you never want that. And that's like the most important thing to avoid while you're soldering is getting cold solder joints. But you can see these are nice, well flowed, it's called wetted. The solder is fully wetting the board. So yeah, so the indicator on the silk screen for the LEDs shows the flat side. So the LED has a flat side on it, and the flat side goes to the short pin. So the short pin is going through the board so that it lines up with the flat side on the silk screen. You can see this right here. So this is an example of through holes. See, we're putting the leads through the holes. And we're going to get them on the other side, and you can usually just bend the leads a little bit to hold it in place. But then also we're going to set the board down on the component side down, which will hold the pieces into place. And that's why when you're soldering, you often start with the lowest altitude or the lowest thickness parts first, because then as you flip it over, you can get basically the table to help you hold them into place, and then just things don't get in your way when you do that. So again, here we're just flowing solder. We're using a little tiny bit of solder to heat up the joint, and then getting the solder in there so that the heat of the joint melts the solder into the joint. And there's just 4 little through hole posts here. It's actually quite easy, and you can see I'm moving pretty quickly because like I said earlier, you want to be able to use the flux, and the flux will disappear over time. See, it's not smoking anymore because the flux is gone. So while the flux is still in there, you want to get the work done. So you do want to move a little bit as quickly as possible without without creating errors or making a mess. So, all right, then we're going to cut the leads off. This is where you need to be wearing your safety goggles. And then some people like to go back. I usually like to do this and hit the cutoff part with the soldering tip again, just to get the solder, basically the wound that was left behind by the cutter, just to make it nice and smooth. But that's your option. And the switch is also through hole. You can put it on the front or the back. I think since it doesn't really matter. Putting it on the back means you don't have to see it. It leaves the board looking kind of nifty. So you can just push it through those 3 holes here. If I can get that to stick in there, right? The leads are really short on that switch. And so here's a good example where you want to get one of the pins soldered, and then maybe just get one soldered here, and then maybe check and make sure the other 3 are the component is lined up, because while only one pin is soldered, you can reflow it very easily and move the component around a little bit. This is important when you're doing like a chip that has a lot of pins, is you just get a corner tacked down, and then you can move the chip around just a little bit by just reflowing that corner. And then once everything's lined up, you can go ahead and solder down the rest of them. But it's even useful for just a little switch like this. There's a lot of play in those holes. You can move the switch around a bit, so it just helps you line it up nice and straight. All right, all 3 pins of those, and that switch is just an on-off switch. It just opens the circuit between the battery and the 2 LEDs. And now these are not just regular old LEDs. They actually have a little circuit inside of each of the things. They're in an LED, a 5mm LED package, but there's a little circuit in there that actually cycles 3 different LEDs inside the package. So each of those packages, while it looks like an LED, it's actually 3 LEDs and then a little circuit that will make some cool flashing patterns. And we're going to get this coin cell open. It's lithium coin cell. I'll show you how to install that. These are packaged really well because the manufacturer of the batteries doesn't want them shorting out and causing any trouble, so they completely encapsulate the battery to keep it safe. So anyway, we take that and we flip the positive side up. Here, let me just show you. There's a little plus on the top. Flip the positive side up, and that obviously means the bottom is ground, and then slip it in there. And the part of the reason why we tinned that pad underneath the clip is because the center pad actually becomes the terminal. And there you go. That's BadgeBuddy. Nice, beautiful blinking lights. It's very colorful, and the lights blink quickly and then slowly in different speeds. And if you leave it on for a few seconds, the colors will get out of sync, which makes it look a little more discotheque. It's pretty cool. Okay, so that was pretty cool. So I said we would talk a little bit about just give you some of the keywords about removing solder. If you need to what's called rework, meaning something's already soldered and now you need to rework it or reflow it, you need to heat the solder up so that you can take the parts apart. Sometimes you want to remove the solder, so you can use this thing called solder braid. Which is basically just this really finely braided wire, and it has a lot of flux in it, and it'll suck if you just put it between your iron and a piece of work. Once it gets warm, it'll kind of draw the solder out of the work. You can also use a solder sucker, one of these guys right here. So you create a vacuum in there, and then when you trigger it, it sucks the solder out. And so yeah, I wanted to point out when I did that, a couple little chunks of solder flux flew out of there, and you do not want to eat that or leave it where a child might eat it. Okay, if you get that on your hands like I just did, you want to wash it off before you eat or floss or whatever you might do that might get in your mouth. All right. Yeah, so braid, suction. Just remember, you're going to need more solder. Either of those things you're doing, you need more solder. You might need flux. Again, you'll figure these things out as you get to them. Just don't be afraid to use more solder. Don't be afraid to get some flux going on things when you need it, or add more solder to get the flux melted in there. All right, so hopefully this is useful. There are a lot of resources online you can find about soldering. If you have any questions, hit us up here at HackerBoxes. Yeah, and like I said, I hope that was interesting. I hope you're open to soldering some more projects. We sell a lot of kits at hackerboxes.com, and there are a lot of fun things out there to solder. Even if you don't get them from your actual kits, just things that you might want to rework or modify or try to repair. Like I said, it's a very handy skill. I hope you enjoy it. Thanks for spending this time with us. Take care.